back. We're going to be covering an Algebra 2 topic today called natural logarithms. Before that, let me remind you what a logarithm is. A logarithm is the inverse of an exponent, and it calculates the power to which a base must be raised to produce a given number. So for example, in this problem, we have log base 5 of 125 equals to x. So what this is asking is, what exponent do I need to raise base 5 to in order to get 125? And this is basically equivalent to 5 raised to x equals 125. So all that log does is help us find the exponent that we need to raise a certain base to in order to get a given answer. And in this case, our answer would be 3. Now that we've reviewed what logarithm is, let's talk about natural logarithms. So the natural logarithm of a number is its logarithm to the base of constant e, which is also known as Euler's constant. If you guys remember, we also see Euler's constant in compounding continuously, or PERT. For example, let's say a population of llamas on a tropical island can be modeled by the equation P equals 500e to the power of 0.035 times t. How many llamas were initially introduced at t equals 0, and algebraically determine the number of years for the population to reach 600? Round your answer to the nearest tenth of a year. Okay, so here we have our equation again. I'm going to label what each part of this equation means, and then we're going to be able to answer the questions. So P obviously just means our total population of the llamas. 500 is our initial or starting population. E is just Euler's constant. 0.035 is our rate, and t is time. Now, right away, I can already answer the first question, which is asking how many llamas were initially introduced at t equals 0, because I already have 500 right here. And if you remember, when we have PERT, P is our starting value, and in this case, P is 500. So the answer for this first question is 500 llamas. However, there is another way you could have solved for this. Let's say you substituted t for 0, so you would have 500 e 0.035 and times 0. So when you multiply these, right, you're going to get 0. So you're going to end up with 500 e and 0. So now you have e, or Euler's constant, being raised to 0. And anything that's being raised to 0 is going to equal 1. So you're going to end up with 500 times 1, which is equal to 500, which is the same thing that we got here by simply looking at the principal value as shown in the equation. Now, our second question is asking us to determine the number of years for the population to reach 600. So remember here, the P stands for the total population of llamas. So the value of P in this scenario is going to be 600. And it's going to be equal to the equation that we already have here, 500 e 0.035 t. So in this case, we're solving for t. So our next step is to isolate t. But to do that, we need to divide 500 on both sides first, because that way we can leave e, or Euler's constant, and t on their own. Once we do that, we're going to end up with 1.2 is equal to e raised to the power of 0.025 and t. Now here is where you can use natural logarithms. What you can do is, if you put a natural logarithm right in the front here, you're canceling out Euler's constant, leaving you with just 0.035 t. Now let me explain. Natural logarithm, as I explained earlier, is the inverse function of the exponential function of e to the power of x. So what I mean is that if we're doing ln of x, it's the inverse of e to the power of x. So if we were to do ln of the constant e, we're going to end up with 1. And you guys can check it in your calculator, but that means that whenever we use a natural logarithm on e, it's going to equal 1, because they cancel each other out. The reason why this is so helpful is because once we cancel this out, now we're actually left with 0.035t, allowing us to then solve the rest algebraically. However, you do have to do the natural logarithm on both sides in order to balance the equation. So to continue, if we do ln of e, they cancel out, and now we're left with just ln of 1.2 is equal to 0.035t. So now all we have to do is divide by 0.035 on both sides. And now whatever we get for this answer here is going to equal to t. And our answer is going to be t is equal to 5.2 years. Now, if you wanted to check your work and do it the regular log way, you can totally do that. So if we just rewrite it as 600 equals 500 e 0.5t. So once again, you're just going to divide by 500 on both sides. You're going to get 1.2 is equal to e raised to the power of 0.035t. And now you can just do log of e, 1.2 equals 0.035t. Whatever you get, you can divide it by 0.035, and you're still going to get 5.2. So just to summarize, remember that a natural logarithm acts as an inverse function that helps isolate and solve for x in Euler's constant, and the natural logarithm of e is equal to 1.